Welcome back to the Superliminal tutorial, and in this part we're going to be working on the portal. So a portal that makes you teleport, but also in addition can make you change size of the character once you interact with it or once you pass through it. If the portal is bigger on one side than on the other, you'll either get bigger or you'll either get smaller depending on which one you walk through. So that's what we're going to be doing in this part. So the first thing I'm going to do is I'm actually going to import the portal asset, which I'll leave a link in the description below for you to get. And so let's drag that in. There we go. So you can import it pretty much with the default settings. Nothing should really matter. So you can have it create two materials. We're only going to actually need the one. So we're going to delete portal 1 and leave the exterior. So what we're going to do with this, so you're going to get some errors here, they don't really matter, it's not a problem. So I'm just saving it. And so with that, the first thing we're going to do is we're going to use this portal in a new actor. So what we'll do is you want to right click on a movable and create a child blueprint. So we'll call it a_movable, and instead of child we'll say TP for teleport. We're going to open that up, and it's still open on the wrong window, whatever. I'm going to swap the static mesh to our portal. So there we go. So this is what it looks like. Normally, make sure the scale is 1:1, it should be. And we're just going to change the material because white is a bit bright. So we're going to search for blue, and we're just going to choose MI solid blue, which is the same as the chamfer cube. Now for the second element, which is actually going to be the inside, so the actual visible portal here, we're going to select something else. So I'm just showing you that this is what it is. You can't see it, only on one side visible. So what we're actually going to do is we're going to apply a material that is going to be using a render target. So we're going to be setting that up now so that we can see through our portals. So the first thing we need to do is, well, let's make those materials for that portal. So go back into here and we're going to go into assets, and we're going to make a new material. So select material, we'll call it m_portal. Now open that up, and inside we're going to make very few changes. We're going to select portal, and we're going to swap it from default lit to unlit, and that's all. Next, from the emissive color, we want to get a texture sample. And for this texture sample, we're going to convert it to a parameter, which we'll call render target. Now, by default, we do need to give it a material, otherwise it's going to leave an error here. So we'll just put default texture. Any texture works, but might as well have one. The last thing we need is what's going to allow us to actually fix the image in space, let's say, to make it screen aligned. So for that, we are going to need screen aligned UVs, and simply attach the 100% X and Y to the UVs. Now, if we move around in the viewport, you can see that it doesn't move. It stays stuck as if it was on the screen. So with that, we're done with the material, nothing else. So we can apply, save it, and go back to our testing. So what we're going to need to do is we need to make a material instance, which we'll call MI for material instance portal, but we'll actually call it portal 1 and call another one portal 2. You can do it this way, or you could modify the material instance later, but we'll just make it simple and have it be MI1 and MI2 pretty much. So the last thing we need to make for these materials is the actual render targets. So we're going to need two, because how render targets work is they can only have one material or one image, let's say, applied to it at one time. So because of this, you have a limitation when you use portals. For instance, in the scenario where you have portal like Valve's portal or the portals that we're going to have here, you can only have as many portals as you have render targets, because otherwise they'll start scanning or sharing the same image on the same texture. So you won't actually have, for instance, 4 portals, you'll only have 2 that show the same thing. So that's one of the issues, so make sure you're aware of that. So let's go ahead and add our render target. So render target is under the textures tab, and we're looking for render target, not canvas. So make sure you choose the basic render target. We'll call it rt_portal. And we're going to create, as I said before, a second one. So we'll call it 1, so we make sure that we know which one is associated with which, and number 2. So mi1 is going to take the portal 1, and we'll do the same for the portal 2, which will be portal 2. Now, by default, these are both going to be black because they don't have any images applied to them. And so that's what we're going to be adding next. Now, with these materials done, we can now go back to, well, our new actor, the A movable. So we can go ahead and open that right here. Now, with A movable TP, there's a few things we need to do. Now, the main thing is we need to do a bit of setup. So the first thing we want to do is we want to get a reference to our player character. So we're going to do that at begin play, so we don't actively do it because we need it to reference what we're going to, let's say, record onto the texture target. So onto the render target, sorry. So we're going to cast to FPS Superliminal. And to do that, we need to get a reference to our player character. So with that set up, we now can go ahead and say save as. So promote to a variable, and it will automatically name it what we want. So compile. The next thing we want to do is we're going to have to go and make a function for the setup of the actor, let's say. So to do that, we want a few variables. The first one is going to be a boolean, which we'll call isPrimary, and the second one we'll call isEnabled. Now, the primary one is mandatory, let's say. The isEnabled isn't. It's just a means to say, for instance, in the showcase I had 4 portals, but the first 2 were separated from the other 2, so I could enable them with this boolean. So that's why it's here, and you don't have to use it. So we're going to set it up as if it's useful, but you don't have to use it. That's up to you. So by default, we do want it to be true though. So this needs to be true. Primary, leave it false, as it's going to determine how to set up the portal, so we don't have to do it ourselves. Next, we're going to need a reference to our other portal, because the 2 need to be linked together. So we're going to get something called linked portal. Now for linked portal, we want to get out a movable TP object reference, and we'll make it public as well. The last one we want is something we're going to call start overlap. So what this will do is pretty much once the player gets close enough to the portal, we'll say, okay, we need to get ready to teleport the player. This is just to avoid doing the logic of checking if the player should be teleported when the player is still miles away, and it's not very useful to call that function. So the first function we're going to make is the setup function. So we'll call it primary setup, because it's going to be based on the primary value here, and the isEnable. So we're going to do an AND with both of these and put it into a branch. So what this will do pretty much is we're going to be calling this in the construct script, so that if ever the portal, once we've placed it, so in our case let's go ahead and add one in the scene, we have 2 of them here. We only want this logic to be called from, for instance, the first one. So here we can connect them, even though they won't do anything. We can use the eyedropper key and select our second portal. And so this is the only one that's set up right now. This one has no information. But once we finish with our setup, it will automatically update the information here. So we're going to go and do that now. So for primary setup, what we want to do is we're going to want to set up the render targets. So to do that, the first thing we want to do is we're going to get our linked portal, and we're going to set its linked portal from within here. So as you probably guess, it's going to be self, because it's at this portal. Now we're going to have to add actually another function here, because it's a bit easier to do it that way than have it all in one spot. we're going to call the function setup render target. So what this will do is we're going to add the render target here for the two portals. So we'll call it render target because that's what we're going to be inputting. And we're going to search for render target. So render target texture, if I'm right, just making sure. Render target, and it should be this one. So the texture render target 2D. So make sure it's an object reference. And with that, we're going to need one last thing for this to work. So inside of here, inside of our components, we're going to need to add a scene capture. Now the scene capture, make sure you choose the 2D one, is in essence, think of it as a camera, because that's exactly what it is. It is a camera placed in the world that will capture what normally would be seen, for instance, by the player, if it were a player camera, and it captures it, and in this case, it's going to set it to our texture target, which is, for instance, our portal 1 or portal 2, which is what we're going to set up right now. So here, get a reference to our scene capture component, and set target. Now it's called texture target here, not render target, so make sure you type texture target or you might not find it. So now the next part is we need to make sure that we set our material to our new material that we created in assets, because even if we film it, if we don't tell it to show the material, it's not going to work correctly. So for static mesh, we're going to say set material. Make sure you select the second index because we have two materials here, one for the exterior, one for the portal. Attach it, and the material we're going to use, we're actually going to need a select node because we need to make sure that we're using A or B. We can't use the same one for both or it won't work. So get is primary, because is primary is going to be the factor that separates portal 1 from portal 2. And so what we want to do is we want to make sure that we put portal 1 for the false and portal 2 for the true. Now you're probably thinking why primary should be 1, right? Well, that's true as the logic would be, but that's primary 1. For primary we're going to have portal 1, but portal 1 is going to be the recorded part for portal 1 for the primary. So for primary we're going to record to portal 1, but we need to see portal 2 from the first port, from the primary portal, and from the secondary portal we need to see portal 1 but record portal 2. So that's how, kind of the logic. That's why this is the primary portal 2. So with that, we finished our setup. We just need to call these functions here. So setup render target on true, obviously. And so what we're going to say here is we're going to set it to portal 1 by default. Now, the second thing we need to do is once we've set up our linked portal, we're going to get and set setup render. And this time we're using our linked portal. Now, the linked portal, because it's not primary, we need to tell it to record, well, our second one. So in that case, we're going to choose portal 2. So with that, the portals have been set up. And now we have an actual image coming through. Now, if we go and look at it, it's not really working, is it? It's completely broken. Now, the reason for that is a few things. So, one thing to note here that we're going to be doing is inside of a texture target or a render target texture, you can actually set the resolution. So let's say normally you would have 1920 by 180. And for instance, if we run this now, after having done that, for instance, you'll see that the texture earlier was very low quality. Now it's smooth, right? It's no longer has that weird pixelized look to it. So the reason for that is because the actual size here is literally based on how high quality the texture will be. So for instance, if you would like to change the resolution and make it less expensive to run a portal, then you would have to change these values. So in Unreal Engine 5, I think it changed in Unreal Engine 5, it might have been 5.1. The scene capture 2D has been got the actual implementation to set render. If I remember well, let me double check. So originally you had to do some C++ here to be able to modify the render target texture. So what I just showed you there had to be done via C++, but in Unreal Engine 5 it has been changed to be exposed to blueprints. So you need to get a reference to your texture target, and you need to then apply what we'll call resize render target 2D. And so this will be our texture. So the reason I'm saying this is because we're going to be using this in the event tick part of the logic. Because if, for instance, the player were to resize this window at runtime, then you'd have a problem because the texture could be either stretched or not working correctly with what the player is seeing in the portals. So now I'm actually going to move that here because we will be using that. So next what we're going to do is we're going to make our portal move so we can actually see things correctly inside of the portal. So one thing I actually forgot to do is we need to attach this to the static mesh because it's a movable object, right? So the static mesh can move, so we need to make sure that it is a child of the component and not of the actor. So that won't change much as far as visuals go, it's still going to be down there. So now we're going to get into the more complicated stuff, let's say. So what we're going to do is inside of the event tick, right here, we're going to add a branch. Now for the branch, we're simply going to call isEnabled. So if it is enabled, we want to do the following logic. So the following logic is going to be what we'll call, let's say, update, we'll say update render target. So I'm just going to just have it all attached. So we're going to call that here, on true. So inside of there, well, that's going to be where we're going to place our resize first. So what we'll do for the resize, we're simply going to call the function get viewport size, split the node, and simply attach them here. And now it'll be done automatically. You don't have to actually go into the settings of each render target, it'll do it for you. So next what we need to do is what's extremely important here is the actual moving of the scene capture components. So we're going to have to get this, well, actually, that's wrong. First, we actually need to get our linked portal, and we need to get the scene capture of the actual linked portal, and not the current, not the one of this actor. And what we want to do is we want to set relative location and rotation. And so what we're going to be doing now is exactly that. Now, there's one thing worth noting that we need to actually change in our project settings before we go too much forward, too far forward for this, but we'll finish this first, sorry. So what we want to get is we're going to need first one more thing in our static mesh to actually get the portal working, or well, like it makes it more simple to work with if we add this. So we're going to add a scene component, which is pretty much just something blank. Okay, so yes, so the scene component is pretty much just an empty actor inside of the viewport. It doesn't have any visuals, you can't do much with it. So what we want to do is we're going to call it the back facing. So all it's going to do is be rotated 180 degrees. So it acts as a mirror to what the player's location will be. So that's what it's for. So that's how we're going to use it right here. So we're going to get a reference to it, and we're going to get world transform. With that, we're then going to search for convert transform to relative. Leave the transform here, split it at the end, and attach the new location to the values here. Then we're going to get a reference to our player that we got earlier, and we're going to get first person camera. And here we're going to, well, get our world location, world transform, sorry. So get the world transform, attach it here, and connect it to the parent. Now, with that, the portal now actually moves. So because it's enabled by default, both of them are connected, as you can see. If we play and we walk around, it looks almost correct, right? And the reason for that is because when we move here, on the back end, or the back side of what's happening, is we have our scene capture that moves relative to the player. So the player is currently standing here, so the camera here should be looking out that way, which is how most of this logic is going to work. So, but you probably noticed there's a bit of an issue here, how it looks like we can see something behind, even though we shouldn't be seeing that, right? So the reason for that is because although the camera is filming what's happening behind like we want it to, there's a little issue. So I'm actually going to show you how that works here real quick. So we have a cube here, and we're going to place it behind our gate or our portal. So if we look at this, for instance, no, sorry, it shouldn't have, oh, it actually moved it. So we're just going to place that there. Now if we look through our second one, as you can see, there's a cube there, right? And that cube is actually being filmed from behind, which is why it looks like that. So that's the same thing that's happening on the edges here that you can see there. So to fix that, we need to actually be cutting the image right behind it. So to do that, there isn't a tool already set up in the scene capture, which is in the advanced tab here called enable clip plane. So that's what we're going to be doing here, but to do that, you actually have to change the project settings. So go ahead and open your project settings. And what we're looking for is called clip plane. And we're looking for support global clip plane for planar reflections. Now, we're not using it for planar reflections, but we need to tick this to true. And we can also modify the near clip plane to something like 0.01. And so what that will do is make it so it's more precise in its cut. So we're going to have to restart the project for this to apply, so let's do that. So we save selected, and now the project will just restart, so give it a second to do that. Okay, so our level's ready. So now we get to the part where we do the clipping. So for the clipping, it's rather simple really. So on our scene capture component, we're going to call simply clip plane base. I'm going to want to set it. And before I forget, we also need to go into our scene component and actually tell it inside of the advanced tab that we need to have it enabled. You can also call it from the reference if you want to do it at runtime for a specific reason. That works as well. For the location of our clipping plane base, so think of this as the point in space we want to start cutting our visuals for the camera. So the place we want is very simple. We want our static mesh. We want to get world location. And we're simply going to call it from here. That's where we want our mesh to, well, that's where we want our rendering to stop for this camera. Then we need to do the same thing for our normals, because right now, for instance, the plane will be perfectly flat and cut the ground, but that's not what we want. We want it to cut the back of the portal. So we're going to get a reference to our scene capture again, and we're going to search for clip plane, and this time we're going to set the normal. And so pretty much the same thing. We're going to get a reference to our static mesh, and we're going to get our forward vector. Now this time it's in world space, so that's why we have to use world location and forward vector. So we can apply this, make sure everything's tidy, and go like that. So with this, our plane is complete. Now if we look at it, we no longer have the weird glitch on the side. As you can see, there's a slight cut here, but there's nothing we can really do about that because it just appears when you move. So it's a bit difficult to get rid of it. As you can see, if we look through here, at no point does the cube behind it appear because we've hidden it. Now that's getting kind of annoying. I'm actually going to get rid of our line traces there because they're not exactly helping, are they? So trace for camera, and we're going to remove that if I remember well. So remember where it is. There we go. Let's get rid of that. So now our thing works perfectly. Now the next step is, well, to make it so that the player can actually walk through, because the collisions aren't set up by default. I'm not sure how I'm going to do that for you guys, if I'm going to upload a uasset. That way you won't have to bother with doing the collisions. I'll run some tests on that. Maybe the collisions will work for you. I'm just going to go ahead and make the collisions now so you can follow along if they're not done for you. Let's see. So get our static mesh, our portal, and we'll open it here. Now by default, we can show collisions here, simple. This is the collisions we have. So if we don't want that, we're going to delete them. And the collisions we want are rather simple, so we're going to use a few boxes pretty much. So I'm actually going to look at what I did before, because that way I have the same thing and it's pretty easy to do. So make sure you just follow along with the numbers I input. So we're going to need 5 different boxes. So the first one that we just made, so they all appear in the same spot. They're all going to appear right in the primitives part of the collision. So the first box, we're going to put it at -7, 82, and we'll put 120. So we're going to be doing the side here. As for the extents, we're going to put 31, 16, 240. So then we're going to make the same thing, but on the other side. So if you want, we can copy here. We'll say -7, 82, and 120. And the 82 is what becomes negative to get to the other side. Then we put in 31 again, 16, and 240. So that will do our 2 edges. So with that done, we then move on to the top part. So we're going to add another box. Now obviously this is my way of doing it. You don't have to follow the exact stuff I do, that's fine. So we want -7 again, because that's the depth. We want to put it at 0, and we want to put it at 232 this time. So we want the top, right? So 31 for the width again, 180 for the length, and 15.5 for the height. Now with this we could call it okay, it doesn't matter, but the point of these is to kind of help it balance out, so that if we move it ourselves, it's easier to just make it land flat and stay straight, because if it falls, it's a bit awkward to walk through the portal, right? So we're going to add still 2 more, and those 2 more will be the last ones. So for the next 2, we're going to put -68, 82, and 50. And for the values, it is 100, 15.5, and 100. So we'll do the same now for the next one. Let's go and add that box. So we're going to put it at -68, at -82 for the other side, and at 50. 100 again, 15.5, and 100. And with that, we finished our collisions. So for the collisions, now if we try it again, we can actually walk through, and everything works fine, no problem. So the one thing we don't want to be able to do is walk through with cubes. We only want the player to walk through these, so we're going to have to add later on a collision, and so we're going to have to deal with that in a bit. So now with the collision set up, we can walk through, so let's work on letting the player walk through. So first what we want to do is we want to add our start check here. So start overlap is what we're going to be using to say, hey, start checking whether the player should be teleported to the other portal yet or not. So to do that, we're going to simply wait here. This is true. On true, we want to add another branch. Now, the other branch needs to check 2 things. First, we're going to get is held. Now, the reason we need is held is because we don't want the player to be able to walk through a portal if he's actually holding that portal, because that will cause an incalculable amount of bugs. We're going to add and, because this is only the first step that we need to check. The second one is a bit of maths, which isn't too complicated to be fair. We just want to check once the player reaches the point where the portal is, where the plane for the portal is, to know that he comes out on the other side. So to do that, we want to get our player location, and we'll say get actor location. So with actor location, we're then going to add to actor location its velocity. So the reason we do this is that we know if, for instance, next frame, the player is moving at this speed, so next frame he will be past that portal. So we want to say, well, he's going to be past it, we might as well teleport him now. So for that, we need to get velocity, which will be at the bottom here. And what we're going to do is we're going to multiply the velocity. And we're going to multiply it by get world delta seconds, which will pretty much say, well, this is how much time will be passed by the next frame. So on the next frame, you'll be at this distance. With that information, we're now going to subtract the value, but we want to subtract it on the bottom side. And we want to get our static mesh. So we want to get world location, and we want to subtract this well, our calculation from the world location. And the final thing we're going to do with this is we're going to do a dot product. Now, oh, sorry, actually, before we do the dot product, we need to normalize this value. So with that done, we can move it up because we're going to need a bit of space, and we'll do a dot product. Now make sure the dot product is at the bottom, and for the top we need sm move, and we're going to get forward vector. Now the reason for this is that with a dot product, we're going to be checking whether at what point the angle at which the player is relative to the forward vector becomes superior to, let's say, 90 degrees on any angle. It pretty much checks if the player goes behind a certain point, let's say, to make it simple. And so that's what we're going to check. We're going to check if the player ever walks behind our portal. And if he does, well, we're going to teleport him. So we want to look for superior or equal to 0, and that goes into the AND. And obviously the next function we need is going to be here. We're going to call teleport. So add that at the end of our render target here, or update render target, sorry. And that's our teleport. Now, we can put a print here to see if it works correctly as intended. Now, one thing we're also going to add in a bit, once I've set up the, because currently it's not actually going to be called because we haven't told it when it can set our overlap to true. So currently right now, normally it would trigger right about there. So the reason it's not doing anything is because we haven't told it what it means to be overlapping. So that's what we're going to do now. So to do that, we need actually 2 different collision detections that we're going to add. So the first one we're going to add is a box. So it's going to be 2 box collisions either way. The first one we're going to call block visibility. So block visibility is going to be 20 by 74 by 112. And the location will be -10 and 112 on the Z. So pretty much think of it as being a door inside of the door frame. So what this will do is it will stop the player from moving a cube through the portal. So we just need to quickly change its collisions because we want it to also physically stop that portal, that cube, for instance, if we drop it. So what we want it to do is we want to make sure that that information is custom, because we can't have it be a default value. We need to change this from query only to physics and query. And we're then going to modify the block here for the visibility. But we also need to make sure that any physics body, because that's the type that the movable is, gets blocked as well. So this is what it should look like at the end. Now we can move on. So with that now, any cube we hold, for instance, let's run the test. If we take a cube here, it won't be able to go through. If we drop it here, it will stop in front. And if we get close enough and we drop it, it will fall in front as well. So one little problem with this is because it's physics-based, it can still push our portal. So what I suggest doing, don't have to do this, it's up to you, is for our physics, we're going to enable the mass and give it something a bit higher. So that way the cube won't usually push it out of the way. Now, we can move on to our second thing, or our second collision detection, which is going to be a more basic one, which is going to be a collision that will call when the player gets close enough, and it will tell it to drop the cube that it's holding. So we get a box collision again. Make sure everything's also attached to the static mesh. I'll mention that again, but make sure it is. We'll call it drop cube. And for drop cube, the size is going to be 60 by 90 by 120. As for position, we want it to be simply at 120. Now, so with that, we have our collisions set up. And so what we're going to do is we're going to tell it, once the player enters our drop cube, it drops the cube, or drops an object that it's holding. But in addition, it also needs to say, well, hey, we started overlapping. So let's take that information and set it up. So we want to get a reference to our drop cube here, select it, and go for begin overlap. Now we're also going to need, obviously, the end overlap. So we're going to get both of those. Start with end overlap because it's just as easy. We want to cast to FPS Superliminal. And we're going to simply tell if it is, we set start overlap to false. We're going to do the same thing on begin overlap, but on begin overlap we're actually going to do the opposite, which is going to set it to true. Now, one thing we actually do want to check as well before this, because this is what we need to do, right? We need to make sure that the object is not being held. Because if the object is held, then we shouldn't be doing any of this logic. It's not necessary. So make sure on false we have cut or cast. So then we're going to call drop object, and as I did previously, remember, we added a held object get validated just to make sure that in this scenario we don't drop or cause errors if we don't have an object. And so we're going to do one last thing here, one last check, and this check is going to be a function that we need to make, and this function is going to be called is player in front. Now what this function will do is simply have a return value, which we'll call simply return value, and this function serves the purpose of checking whether the player is in front, because we don't want to walk through the pool if we're coming from the back of the frame. So set it to pure, and back in event graph we can attach it here, and on true, so if we are in front, we can set overlap to true. So we're going to set up is in front very quickly. It's not that long. It's pretty much the same thing as the dot product we did earlier, so we can copy actually most of that. So we're going to go to our update render. We can copy everything here, and we're just simply going to get rid of our plus here, because we don't want to take into account the speed when we enter, because it's unnecessary, let's say. So here the same thing. In this case we actually want to check simply superior, although superior equal does also work, so we can just leave it as it is. So compile and save, and now we can run a test, for instance, to see if we teleport, and it should work. So if we go through, so it didn't work, so something's wrong. So let's have a look and see if our overlap is indeed getting called. So let's print, let's try that again. So for some reason we're not actually overlapping, so let's double check if this is, so it's correctly there. Maybe forget the collisions. No, it sets overlap all dynamic. There's no reason it shouldn't be triggering. Let's double check if we're actually getting an overlap, a basic overlap. Let's go and see. Okay, so it is detecting our overlap. It's detecting, let's see if it's printing is held false. Okay, so it knows that it's not being held, so that's working as well. So let's cast to our value here, so let's print, see if we're indeed dropping the object. So now we know, okay, so it knows the player is indeed coming in, so that means there's an issue with our is in front. So let me just double check I did things correctly. Okay, so the reason it's not working is because these two need to be reversed here. So let's just do that, and that should function correctly. Just make sure. Let's try this again and see if we get our print in the teleport. So let's just replace that with teleport. Let's try. And if we walk through one of the portals, we get teleport. So it does work. So the hello is from here, so that works as well. So everything is functioning correctly. So the reason it printed multiple times is because we don't actually move, so it considers us behind until we leave the overlap. So now we can do our teleport. So this is, I wouldn't say it's the most complicated part, but it's definitely the most important part. So we're simply going to go through our different variables that the player would need to transfer once moving, and we're going to transform them relative to our portal. And then we're going to apply that transform to the transform of the other portal, which will then make our player move, or at least how he should once coming out of the portal. So we're going to need a few local variables here. The first one we'll call L velocity, which is going to be the velocity of the player, because without that the player would kind of teleport and stand still, which would feel awkward. So it needs to be a vector type. We can apply it there. So To get the velocity, what we need to do is we're going to get a reference to our static mesh, and we're going to get world transform. So with the world transform, we want to transform direction. So make sure you select inverse first, because inverse will take it from world space to local space. So what we need is we need a reference to our player character here, and we're going to get its velocity again. So with its velocity, we plug that into direction. And now we need to do the same thing, but with our linked portal, and we need to do the opposite. We need to try to take it from our world space and then apply it to local space. So we say, we also need to get the back facing first. Because the reason we need the back facing is without the back facing is the mirror, right? So we need to take that into account. So we want to get its world transform. So get world transform for that, and we're this time going to call the transform direction again, but this time the normal one. And it'll change it from local to world space. But the world space, instead of being relative to the portal we go in, it's the portal that we go out from. So with that, we've set up our velocity. We're going to follow pretty much the same logic for the location as well. So we can duplicate velocity here, and we'll call it location. And so for location, we'll drag out and put it here as well. We can pretty much grab the same information. So these two are always going to be the same. So we can grab those. So make sure you don't grab the direction because it's going to look the same, but it's not location that we're getting now. So we're going to get back to location. And this time we're not using the direction like here, but it will look the same. We're going to transform location, or inverse to be precise. And then here we're going to actually transform location. So with that, we've applied our location, we've applied our velocity. All that's left is the rotation. Now the rotation is a bit different because for the rotation because how the player character works, it's based on the player controller. So you can't just say set actor rotation. You need to say set controller rotation. So we're going to do the same logic once again, but this time we don't use the first person character. We're going to use the get controller. It's like this one for the pawn. And what we want to get is the get control rotation, which will pretty much be the rotation the controller has. And we're going to inverse transform rotation. And here we're going to transform rotation. And we're going to apply this to a variable we'll call L rotation. So you can call it camera rotation if that makes it easier. It's fine. Now with these values, we're now going to apply all this rotation. So what we're going to do is we're going to get our FPS here. We're going to say get controller. And we're going to apply our new transform here. So set control rotation. And with that, we want to get our rotation here. Call it there. Next, we're going to do the location. Now, one thing you have to do for the location is we're actually going to grab the location here and our player character. And we're going to say set actor location and rotation. But we're going to leave rotation empty, because it will be set up automatically with the controller. And finally, the last one we want is we're going to get our character, and we're going to get character movement. And with character movement, we get to set our new velocity. So set velocity, this one at the bottom, and we're going to apply our new velocity. So with that, we've finished our teleport. Let's give it a try. Normally it should work. So let's actually move this out of the way so it doesn't bother us. Let's go. And we came up the other side. It did indeed work. Now, we can try going through the other side and see if that works, but it doesn't because it realizes that it's coming from the back, so it doesn't allow us to teleport. Now, one other thing we need to do, because right now, if for instance we go here and let's say we scale this one up, let's put it at 2. If we go through this one here, visually it looks right, but the instant we walk through, we kind of fall because we're not actually being rescaled. So to do that, it's rather simple. We're going to go into our first person character and we're going to create a new function we'll call Resize Player. Now, for Resize Player, let me just get a reference to it so I know what I'm doing. So for Resize Player, it's not too complicated. We're going to need a value, which is going to be the new size, and it's going to be a float. And to set the float, to use this float, what we're simply going to do is we're going to get actor scale 3D, and we're going to multiply it by this new scale. So get new size here, and apply it. And what we're going to do is we're going to, well, set actor scale 3D, and apply that here. And with that, we're done. We finished our character. But some extra stuff you can do to make it kind of feel a bit better, because this, although it will work, it'll feel awkward because nothing really gets modified other than the size. So what we can do is we can say set max walk speed, and we can change the walk speed. So for that, we also want to get our max walk speed, and we're going to multiply it by our new value, which is the new size. So this will pretty much scale it up to being more appropriate to the size. Now, this is up to interpretation. If you want it to be not exactly one-to-one scale with what you physically change in size, that's fine. We can also do the same for the jump, because we want to be able to jump higher. So we want to get velocity jump Z, multiply it, and we're then going to set it to, well, jump velocity Z. So set jump velocity, I'll attach that there and apply it here. Now, one other thing that I would suggest changing is gravity. So we'll do that. So we'll set gravity scale, and here get gravity scale. And once again, same logic, we'll apply here. There we go. And one of the last things, which I consider is kind of the most important one, is we also want to make sure that we scale up the size, or the reach, let's say, of the character. Because currently right now, even if you were 10 times larger, he can't exactly reach any further. So we're going to actually change our max range as well. So get max range, put our multiply again, and attach it with that. Now, the last thing we need to do is call this function, and to do that, we need to go back to our TP. And right here, we'll do it before we change the location. We're going to modify our scale. So let's get that. And for the scale, what we need is we need our player character. We're going to set size. I think that's what we called it. Scale? No, I think I named it Resize Player, sorry. So we call Resize Player, control drag to avoid reattaching two lines. And for the size, usually, in most cases here, or at least the case I've used in, we're going to get world scale. Oh, sorry, get world scale. And we are going to split it, because you can't really, because we're using a scale and a float, there's no real point in having it be something different. As in, how to put it, unless you use a non-uniform scale, then you might need to do this differently, but in my case, I never really use that. So we get our linked portal as well, and we want to get static mesh, and we're simply going to divide these one by the other. Now, make sure that you have the top one be linked portal. We're going to divide, and see I use Z by X, even though that's not the best way to do it, but if they're scaled uniformly, it doesn't matter. And with that, we've set up our resize. So let's run a test, see what happens. If we go through here and we walk through, as you can see, we're larger, we can jump, but we still feel heavy. Even though we're much larger, we've changed the values so that works. Let's go back through. Same thing happens here. If we go through here, we get smaller, we still feel heavy, even though, as I said, it's up for interpretation. If you want people to get larger jumps when they're small, then you can do that, and that's just fine. We go back through, we get bigger again, or normal size. As I said earlier, if we hold this and try and walk through, it's not going to let us. It will force the cube out of our hands. And so I believe that with that, we've finished our portal setup. It's completely done. I hope you enjoyed the video. Let me know in the comments if you have any issues. I'll try and help as best I can, but I hope this one was more clear than the Viewfinder tutorial. I hope it was, because I really put in a bit more effort here. So thank you for watching. I'll see you in the next part, maybe. I'm unsure, there are some extra little bits in the showcase that might be worth sharing. If you're interested, let me know. I can add the other little parts that I did in the showcase to a third part, a bonus part if you will. Thanks for watching, I'll see you in the next video. Goodbye.